Welcome to the end of chapter problems for chapter 1. Let's proceed and solve these problems. Let's see if we can get to first problem. We are asked here to determine the SI units of the constant of proportionality G in Newton's law of universal gravitation. We are told that F sub G, the force of gravity, in SI units is derived from the combination of kilogram times meter per second squared. We're also told that M1 and M2 are each in the unit of kilogram, and R is in the unit of M meter. So first, let's solve for the constant of proportionality G. And we see that G is equal to F sub G times R squared divided by M1 times M2. Now, let's solve for the units. F sub G is in kilogram times meter per second squared. R squared is meter squared, and M1 times M2 is kilogram squared. We can see that this kilogram will cancel one of those, and when we multiply them out, we get meter cubed divided by kilogram times second squared. And that is the unit of G. Next problem. A standard page is 8.5 inches by 11 inches. If the page is 2 millimeters thick, what is its volume in meter cubed? So this is a conversion problem, and the first thing that we need to do is to determine what is the conversion from inches to meters and millimeters to meter. Then we know that volume is length times width times depth, in this case thickness, and so if we multiply all three converted numbers, we should arrive at the volume of a standard sheet of paper. Okay, well in the back of the book, we see that 1 inch is given by precisely 2.54 centimeters, which we can write as 0.0254 meters. We also know that 1 millimeter is equal to 0.001 meter. Now we take each of the lengths that is given to us, 8.5 inches, and we multiply it by the conversion factor, 0.0254 meters is equivalent to an inch. Next, 11 inches times its conversion factor, 0.0254 meters divided by 1 inch, times 2 millimeters multiplied by its conversion factor, which is 1 millimeter is 0.001 meter. And we can see that upon multiplication, the units cancel out algebraically. And so the volume of the sheet will be given by 8.5 times 0.0254, 11 times 0.0254, and 2 times 0.001. And the result will be in meters cubed. And in fact, it should come out to be 1.21 e to the minus 4 meters cubed. Next problem. A fountain of water is located at the center of a circular pool whose circumference is 15 meters. The student stands at the edge of the pool and calculates that the angle of elevation to the top of the fountain is 55 degrees. How high is the fountain? Well, this is a trigonometry problem because what we can do is to note that the uh, angle of elevation of the fountain, which we're going to label as H, the angle that the height of the fountain to the angle of elevation describes a right triangle. We are told that the circumference is 15 meters, and because we know that the circumference is equal to 2 pi r, 15 meters equals 2 pi r, and therefore r equals 15 meters divided by 2 pi. So to determine h, we take r, 15 meters, divided by 2 pi, and we multiply it by the tangent of 55. Since the tangent of 55 from this triangle is equal to h over r. Here, our result yields 3.41 meters high. Next problem, and last problem. The standard kilogram, in other words, the standard that defines 1 kilogram, is a platinum iridium cylinder of height 39 millimeters and diameter 39 millimeters. What is the density of the material, which is platinum iridium, in units of kilogram per meter cube? Well, we know that because the standard defines the kilogram, this cylinder must have a mass that is equal to 1 kilogram. We also know that the definition of density is mass per volume. So we proceed to write the mass, 1 kilogram, divided by the volume of the cylinder. And we recall that the formula for the volume of a cylinder is pi r squared h. Here, r is given as 39 millimeters divided by 2, which is, of course, 19.5 millimeters. And instead of, we can quickly write the conversion factor because we know that 1 millimeter is e to the minus 3 meters. So we can save ourselves a few steps of work and just write the radius as 19.5 e to the minus 3 meters, the whole thing squared. H, the height, again, given to us as 39 millimeters, can be written as 39 e to the minus 3 meters. Now, we plug the numbers in the calculator and we find that the density is 21,464 kilograms per meter cubed, or in 3 significant figures, 21,500 kilograms per meter cubed. Well, this concludes our problem solving session for these lecture notes, and we will see you next time.